Yeah, I don't think we need to tell Zig what that is. It just kind of figures it out. I hope.
Yeah.
Oh, when it's used. Great.
Should we
Well,
see? Let's double check. It's all good.
And what we'll do.
I'm streaming on Twitch. And I got the little restream brand. It doesn't look nice up there. Okay, anyways. YouTube is the one that's not really cooperating yet. Still sending data. Okay, hopefully that's going soon. Okay. But we are live on Twitch. Okay. All right. Pretty cool. I have OBS down here. Don't actually have any binds, do I? No. Did not come prepared. So if I toggle this, there you go, you can't see the screen now. Now I can send Discord messages. Okay. Let's get on with it. I'm going to leave it down here. Open another browser tab. Go up there. There we go. And then we can open the terminal. Okay. So what I'm going to do is I'm going to learn Rust all the way from the start using the Rust book. So here we are, learning Rust. Learning Rust. There we are. Okay, I've got no idea how to do this, how to use it. Oh, you have my camera up there, so I'm gonna do this. Just make sure this is okay. Oh, you can't even see my screen anymore. Can you? Should be able to. Yeah, you can. Cool. That is a bit too big on the camera. I'll turn that back a little. Okay. Nice. All right, let's start. Learning Rust book. So it's this book I want to read. Got a drink. Got a few hours. Nice. Oh, and my mic is quite far as well, isn't it? So let's bring it a bit closer. Okay, this should be a lot better. I hope. All right. So the Rust programming languages. The Rust programming language. Cool. Let's actually read this. It wasn't always clear, but the Rust programming language is fundamentally about empowerment. No matter what kind of code you're writing, Rust empowers you to reach further, to program with confidence in a wider variety of domains than you did before. Take, for example, system-level work that deals with low-level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane, accessible only to a few. Rust breaks down the barriers. Yep. Yeah, you know. Okay, cool. Okay, let's see. Rust provides a productivity tool for collaborating amongst large teams. We have Cargo, we have Rust FMT, and the LSP, which I need to install both of these. Companies, open source, okay, very cool. Okay. Let's get started. So, we need Rust up. No, actually, Rust up is to manage their versions. Do I do this? Yeah, okay, I'll probably do this. Let's just open another Tmux thing. So, Rust up, the Rust toolchain installer. Okay. Rust up and Rust are in conflict. Oh, I already have Rust installed. Okay, let's, no, whoops. Let's get rid of Rust. Let's install Rust up, which I think just gives you the versions. Cool. What else is there? In the chapter, yep, nice. Yep. And then what? Rust up. Check, run, show, update check, default. Man set self. I need an install. Rust up install. No, what's going on there? Rust up update. Okay. I clearly missed the step, I think. The command line downloads the script and starts installation of the Rust up tool, which installs latest stable version of Rust. Oh, it's there already. Cannot choose a version of Rust because one wasn't specified and the default specified. Rust up default stable. Oh, okay, cool. Got you. Oh, and we got Rust FMT, Clippy, Rust docs, Rust is standard library. Rust. Okay, do we got Rust up? I want to Rust up install LSP. How do I install language server for Rust? I'm guessing there's a thing with this now. Rust up LSP. Rust analyzer. Okay. There, here. Rust up component add is Rust source. Okay. So I think we're installing this. The source code of the standard library. To add one should be able to install Rust Analyzer binary and have it automatically work. We're not there yet, so the editor specific setup. Okay. Okay. Building from source. No, thank you. Oh, it's down here. Okay, nice. And I find vim lsp config. I think this is how I do it. It's been a long time since I've done something like this. Config, new vim, Lua, custom. I use the preset nvchad. For those that don't know, it's pretty cool. I can get rid of this. I'll leave it on. It's not the only one. Configs. Just need the name. There's probably an easier way to do this. There's also not Maven. It's called Mason. That kind of does this for you. RLS. Rust Analyzer. Is it just Rust Analyzer? Great. Let's do that. Okay. That should be working. Okay. Here we are. Alright. Let's create a project. Okay. So in here we're gonna go hello underscore world slash and hello underscore world. We're gonna do main.rs. Let's be info. Rust unable to find executable. Please check your path to ensure server is installed. No, we're gonna have to do some debugging. That's not okay. So what did we do? We added. It's up to date. I'm already regretting decisions. What is this? Rust analyzer. Come on. nvim lsp rust analyzer. Why is this just not doing its thing? Rust analyzer, yeah. Maybe I just do it through Pacman and it works better. Yay, Rust analyzer. I'm always skeptical of like these slightly custom like package managers for languages. Like not for like dependencies, but for versioning and stuff like that. It seems a bit. Okay, now that the binary should be installed. There we go, working. So I probably did something wrong, to be fair. Like I added the component, but I didn't do something specific. I don't know. Good, let's continue. Okay, so we can have function main. Not you. It's not, I'm not getting LSP though, am I? 0 clients attached. Asynchronous root diff functions are not supported in LSP info. No, that's not it. So what? Why hasn't it started? Oh, come on, bro. Okay. Print line. Hello world. And I need one of these. Rusts. Okay, let's go into hello world. Rust C. Main.rs. Alright, we get a 4 megabytes binary. That's nice. I mean, it's fast, but it's 4 megabytes. Okay, what is going on with nvim rust analyzer? It's just not cooperating. Okay. The rust analyzer go to fish service. Is it the maybe I need cargo? No, that's what it wants. Okay, so yeah. Okay, now now we can have cargo, I suppose. Okay, cargo. Hello cargo. cd hello cargo. Let's actually go back here. Hello world, we have hello cargo as source main. Okay, and Rust Analyzer boots up. This is one criticism I had before going into Rust, but I also heard other people have, is that did this create a Git directory? I don't want you to. You're okay. I do want it here. And there's a git ignore target. Maybe we just do / this is any target and move you back a few. No, what's going on? Target's not being ignored. Is it this? No. If I go / hello cargo target like this, still nothing. That's pretty strange. If I ignore hello cargo like this, why is my my terminal's being pretty strange? Okay. So what? I can go all/target. Okay, there we go. So I can't use like relative paths or something. Dot slash. Anyways. All right. This was the hello cargo, hello world, and I can go cd hello world. No, not hello world. Hello cargo. And is it cargo run? Yeah, nice. Yeah, create some. So it creates like TOML stuff. Let's take a look at what that looks like. Version 3. Hello cargo 0.1.0. Okay. Okay. We can build and then we can run directly. Or we can do cargo run. Using cargo run is more convenient than having to remember this. Yep, that's true. Notice that this time we don't have to. Yep, nice. Cargo check. Cargo check. Unoptimized plus debug info target. If I do, yeah, cargo build -- release. If I go cd target, cd release. Yeah, hello cargo is now 420 kilobytes, which is much more kind of appropriate. I wonder what hello cargo.d is. Or some directory stuff. Okay. So far so good. Looks good to me. Cargo is convention. With simple projects, cargo doesn't provide a lot of value, but it will prove worth when the program is more intricate. Yeah, that makes sense. I guess most languages have their own build system. This seems good. Okay, programming a guessing game. Let's jump into Rust by working through a hands-on project together. Just checking my phone, one sec. Should also check on the stream. I'm just gonna mute for a second. Check on the stream. Hello, test. Hello, test. Hello, test. Hello, test. Hello. Okay. So we got Demetra in the chat saying that JS is better. JS is not better. Can say. Although it's not a great start. A lot of intricacies. Alright, we have a lot to get through. Let's keep going. Okay, we'll implement a classic Venus programming problem, a guessing game. Here's how it works. The game generates a random integer between 1 and 100, and it will prompt the user to guess. Okay, yeah, I remember this. So let's create another one with cargo. Let's do a function. Yeah, this syntax is interesting. I wonder how the LSP handles that. Cargo new guessing underscore game. cd guessing game. Main.rs. So we're going to do use macro use. That's interesting. Whatever that was. Okay, we're going to print some stuff. Let's print this. Let's put this here. Consider importing this module. Nice. So maybe I can have code actions, change visibility to pub crate. Can do. Pub crates. Oh, okay. Consider importing the module. Let's import the module. There we go. We have a guessing game. Let mutable guess string. Ooh, look at that. That's so nice. UTF-8 growable string. So it's a pub struct string which contains vectors of u weights. That makes sense. You can do from, or you can append. Nice. Okay, we do io.standard input. I wonder how this. So if I go io dot, so the dot does some funky stuff. Colon for namespace, then it starts. Look how nice the docs are actually. Look. So we have standard in, construction new handle, note Windows portable consideration, sync, empty, blah blah blah, like a lot of stuff. Pretty nice. So far, Rust Analyzer, you seem really good. And so IO is the namespace. Traits, helpers, and type definitions for core functionality. Standard IO module contains a number of things. In Rust, what is the syntax for? I think it's namespacing. The function is namespace by function by the struct. The colon syntax is used for both associated function and namespace created by the modules. So, oh, this comes in at 5.3 on the book that we're learning. So you do right rectangle. Yeah, so it's a namespace to a struct. Yeah, very interesting. Interesting they take this approach instead of the dots. Because like Zig, for example, just uses the dots, and I don't really know what the real differences are there, to be honest. But anyways, and I wonder if I have the format is not going. Is it linter formatter rust dash fmt? Rust fmt. Rust fmt. Format Rust code. Said this is deprecated. No, 3 days ago. That seems pretty. To run on a cargo project in the current directory. Cargo fmt, but this wasn't working for me earlier, so I'm going to install it just through here. Yay, Rust is fmt. Rust dash fmt. No. Oh wait, no. There's the nightly build up there. Rust fmt. Nightly build number 4. Consider package will have. Oh, I think packages will have to be confirmed manually. I mean, it should be working, but I don't know what's up with these dependencies. But let's just try it like this, and maybe I'll sort stuff out. Failed. All right, never mind. Oh, come on, why are you being annoying? Where's this? Rust up, component, add, Rust fmt is up to date. Great. So then, cargo fmt. Yeah, but how do I get it to do that on save? Because it's not, it's like not picking up here. Nvim, Rust fmt. Onsave. I mean, I have the onsave functionality, but it's not really. Go from position. No. For anyone who came here via Google or whatever and is wondering how to enable Rust to save, just add this to your config. Let G Rust to auto save equals 1. Really? Covered in the README. Okay, Rust fmt. Command will. Oh, this is from Rust Vim, but I don't want Rust Vim. I just want the syntax. Oh, come on, bro. Like Vim, Zig does this automatically, and it's so nice. Why can't you? Okay. Anyways, so we do a read line that's namespace itself, and we take in a buffer, which is a mutable string, and I have to pass mut there. Expected mutable found string. Arguments to this method are incorrect. Nice. So I have to pass this. And the expect returns the contained OK value, consuming the self value. Okay. Panics if the value is an error. Okay, so it does the. Okay. So yeah, this result value that returns OK or not OK. Rust cargo run. Enter your guess. 54. Great. Yep. I think I kind of understand all of these. Yeah, immutable, mutability, comments. Nice. Receiving user input. The purpose of result type is an encoded error handling information. Result variants are OK or error. The OK variant indicates the operation was successful. The OK, yeah. The error returns bad. If you don't call expect, program will compile, but you'll get a warning. Okay. Use let equals ignoring the result value. Val. Okay, and we get result. What is this? Unused value. Use variable by default. If this is an intentional prefix, we'll then score val. Yeah, I can do. Was it switch? No. Okay. So let's call the expect later, and then we'll deal with some other stuff. Oh, and then it just injects guess into that. That's pretty nice. I don't have to do like a comma and then add stuff. That's interesting. Okay. Okay. Oh, but if you do empty, then you can put it there. Yep. Yep. Generating a secret number, so we have a round crate using a crate. Wait, really? This isn't on the standard library. Next, we need to generate the secret number should be different every time, so the game is fun to play. We use a number random generator for this game. Rust doesn't yet include a random number functionality in standard library. Are you serious? Rust standard library random number. What? What? Why? Are you serious? Why do I have to install a crate for this? This is not okay. Build shut the box once you get more comfortable. How did you do this? Shut the box? Just turns the computer off? That would be fun. Well, hopefully I'm not leaking anything there. Actually, I still don't know what's going on with YouTube. Still sending data, but it's not working on YouTube. So, not sure. Just on Twitch. Okay. Anyways, let me actually just turn off the screen for a second. I just want to go on Discord. Just invite a couple of friends. Okay. Somehow. Okay, this is not a good start, Rust. Disappointing me. I need to install a crate to get random number. I'm very tempted to call bash function for this. I'm going to do that after we install the crate. Okay. Remember that a crate is a collection of Rust source code files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code. Okay, yes, pretty standard. Cargo's coordination of external crates is where cargo really shines, but we can write code using rand. We need to modify. I need to modify this directly. Surely not. Clean, do new init, add cargo, add rand. Yeah, I mean, I thought surely it would do this for me. Okay, as the lock gets random. My God, why this? It's like JavaScript code. It's got so many dependencies already. Okay, fine. Cool. And they want me to build the thing? Okay, let's try that. Cargo build. That took too long, but okay. But it's compiling rand, which depends on rand shut sha rand core get core ppv light cfg and libc. No, compast. Libc, no. Rust, what are you doing? Okay, fine. This isn't this. Okay, not impressed. Not getting impressed. Actually, let's go on crates. IO. Tokyo. I can find. Can I make this joke finally? Yeah, don't see it here. Anyways. Okay, yeah, the log file, updating a crate. Okay, so I can do update, nice. Generating a random number. Okay, so up here, let's do let secret number equals rand. Nice LSB, very fast. Why are you not importing rand? What is it? Retrieve the lazily initialized thread local random number generator seeded by the system intended to be used in method chaining style. Ender random generates random values in the thread local random number generator. It's simply a shortcut to thread nrg.gen. Okay. So it's a shortcut. Gen underscore range. Oh, and then this is the range syntax, isn't it? The 0 dot dot. Can I not do 100? I have to do equal 100. Oh, what? If I do this, oh, it's non-inclusive, isn't it? 0 and equal 100. Actually, they probably talk about this. Okay, the gen range method takes a range expression as an argument and generates a random number range. The kind of range expression we're using here takes the form start dot dot equal end and is inclusive on the lower and upper bounds. So we need to specify 1 dot dot equals 100 to get one between 1 and 100. Okay, that makes sense. Okay, so okay, I'll take it from here. Yeah, size 4 line. Oh, that's really nice. Tells us a couple of things. This is the guest. This is the guess. You have guessed. We can go if. Can I do just this? No, I need a block. I love the LSB help there. If. Oh, I need to do guess dot to not to owned. That's a yeah, that's in Zig as well. So I need to convert a guess and a secret number, which I'm guessing they will talk about. Okay, guess.compare to the secret number. Really? Match guess.compare. Huh. How about that? Change center bracket and point this to the secret number. So this actually just Okay, first we need to add use statement to bring the type called compare to scope from a standard library. The ordering type is another enum, less greater or equals, and there are 3 outcomes. Okay, I love this. It's really nice. The compare method compares 2 values can be called on. Wow, interesting. So I really want to go into this and hopefully It lets me. Oh, this is macro stuff, isn't it? Yeah, this is macro stuff. Basically, I wanted to see how it did the conversion. Alright, anyways. Okay. If it's less than, print line. This is a macro too small. But do I not need semicolon? Oh, it's a comma. Not bi greater equal correct. Arguments from this method are incorrect. How about no? No parentheses. They don't want parentheses. Okay. Expected reference string found reference integer. Yeah, that's kind of what I was gonna say. I was surprised that did it automatically. The match expression is made up of arms. Okay. Match construct is a powerful for Rust feature. Okay. Make sure you handle them all, so exhaustive switches, yeah. Will return because this is greater, blah blah blah. Won't compile because exactly. Okay, let's actually cargo build. I want to see those errors. They're nice, aren't they? Argument this method are incorrect, expected string. Yeah, this is nice error. Notes. So far, yeah, Rust compiler is really nice. Let's just quickly check on the stream. Who is here? Oh, we got Dimitro. Oh, JS so bad, mid module's bad. Meanwhile, Rust, did you check for is odd crate already? Oh, okay. Crates.io. Let's check. Is odd. Oh, it's there. It's there, Dimitro. It's here. It's updated 7 months ago with 4,000. Yeah. Rust devs, man. They've really gone and done it. Look at this. Currently, the library doesn't support floating point numbers. Why? Sorry, I think I'm giving everyone just no, look at this. No, that's not okay. We got is odd. There's 5 contributors. No. There's tests. Oh, come on, bro. That's not okay. That's not okay. What? I don't even know what this means. Wait. This is a macro. Prim implied. Oh, takes in first head and tail that can have 0 or more arguments, and it returns this injecting this type. Okay, so we implement the isOdd trait for all these different types, and we kind of recursively do this in a macro. I wonder how the LSP behaves around this stuff. Yeah, the LSP might behave a bit strangely. We got 3 views. Can I pop the chat out? Oh no. Bro, just do npmi is odd. Yeah, and call it from Rust. 100%, probably faster. Boys, how do I pop the chat out? Okay. Well, hold on, 1 sec. Where do I go? I'm so confused as to what I'm doing. Create a dashboard. Let's hope I don't get docked. Stream manager. That sounds promising. Pop out chat. There we are. Okay. Nice, nice. Bro, just do NPMI. Rust bad use C. Good point. Good point. Sorry, let me use some C. I'm gonna use C until I segfault. It will take me 2 seconds. How are you doing, James? You alright? James is Acorn, very big shot in London, working for a B Corp, or so they say. I'm chilling. Very nice. Very nice. Shouldn't you be at work? It's Friday. I took the day off, but B Corp status pending. Oh, sorry, Mo. Sorry. I am working now. Put the CEO watching. Yeah. Maybe you want to convert your stack to Rust after this stream. All right. Let's keep going. I figured out how to pop out the chat, so it's nice. Okay, how do we convert this number then? Nice error messages. Thank you. So the core error is mismatched types. Yep. Okay, thank you. So we can transform the guess into a U32. Really? The secret number is an I32. Okay. So we guess, we trim for some reason, we pass. Sounds dumb, but okay. Let's not actually give it any type help. I want to see what it comes up with. Dot trim returns a string slice with leading and trailing white space removed, because I need that. Oh, for the slash ends. Yeah, okay. And we do a dot pass, returns a result with f as from string or error. Pass this string slice into another type. Oh, is that why I need the type help? Please type a number. Oh, it doesn't know. Oh, wow. That's so cool. Because now I can tell it what type I want. And the pass will look for my type. Yeah, that's cool actually. See that? Like if I can do anything here and the pass will very interesting. Let's get rid of that for a sec. And let me do number guess here. Cargo run. And use imports. If I do a -2, it crashes. Please type a number into it. Wow, that's really cool. But now if I turn you into an I32, and then I go for -2, it works. That's really cool, actually. This reminds me a lot of Haskell, where the type system is so much more involved in like decision making. Like if you did this in, I know TypeScript's not a very good example because it's a dynamic language, but if you did this in, like, this is complete nonsense in JavaScript, right? You can say string or number, but it doesn't actually affect the runtime of the program. It's mostly because it's a fancy type. It's a fancy linter, right? TypeScript, if we really think about it. It's pretty cool. Haha, Rust is environmentally friendly, apparently. Hello, Isaac. Welcome. Popping off for how many views we on? We got 3. They're all friends, but you know, it's pretty fun. But yeah, this is pretty cool. I love the type system being involved. This type of stuff is really fun. Really great. Like, yeah, it just produces much more reliable programs, as if you're doing mini unit tests the entire time. Pretty cool. Cool. All right, let's keep going. And now, let me see. Maybe I can figure this out then. So we guess the match on the number guess. Arguments this method are incorrect. Are you sure, man? Guess.compare. Oh no, it's number guess.compare, because it implements the compare trait and then it does number guess, not number guess, secret number. And then it's yeah, now it should work. If I run 2, you guess 2, guess too small. And I need to go around the loop. Do I need to read line into? No, I think I can probably do like a for loop here. This is where it's going to, but let's check out the syntax. This is cool. Let me actually read this. We bind this new variable to the expression guess.trim.parse. The guess is the primary reference to the original guess variable. The trim method, does a couple of things, which we must do to compare. The user must press, The parse method on strings converts a string to another type. Here we use it to convert from a string to a number. We need to tell Rust exactly the number that we want. Tells Rust Rust has a few built-in number types. This is cool. I feel like we're kind of not doing that much about this. Oh, and then the .unwrap goes to an error. Like, what does the unwrap do? If I didn't do an expect, the number guess, what is unwrap? Returns the contained OK value consuming the self value. Because this function may panic, its use is generally discouraged. Right, I understand. Oh, an unwrap error, unwrap or and check for default. Okay. Pretty cool. Pretty cool. Nice. Okay. Okay. The parse method only works on characters that can logically be converted. Yep. Okay. Great. So now we need a loop. Oh, what is this? The loop keyword creates an infinite loop without a loop. Really? This is just a jump over and over again. Okay. Typing quit. We'll quit the game afterwards. That's what they want to achieve. Okay. They're gonna break. Handling invalid inputs. Okay. So let's start. So here the equals. Let's actually do. I think we need a loop here. And let's go down here. Yep. Oh, no Rust FMT. That's so annoying. 13 loop indefinitely. Loop is used to define the simplest kind of loop support in Rust. It runs the code inside until it breaks. While let and for. Yeah. Okay. So wait, does break work inside here? I thought this would only exit the current scope. Exit early from a loop or labeled block. Oh, it doesn't just. Okay, so it has to be labeled. So if I was to label this, label fat arrow. Okay, that's a great token name. Okay. Does this work then? Cargo run 5, too small, 60. Didn't like that. Please type in a parse type invalid digit. Okay. Why is that invalid digit? Please enter your guess. Do I need to move this inside? Do I need to like recreate it each time? Is it because it's adding some stuff on? Too small. 60. So it was pushing to the end, it seems. Too big. 30, too small. 35, too small. 50, too small. 55, too big. 54, 52. Nice. You win breaks. Yeah, nice. Who else we got in the chat? Nothing else in the chat. Anyways. Okay, now we can do a match expression directly assigning to a variable. Like so. Find equal match on this. Go for a scope. And then they do OK. Num Oh, and it pulls out the value that's extracted from, that's inside. Error, continue. Or do I have to do that in a scope block? No, doesn't seem like it. This is intentional. Oh, we ignore the value underscore. That's wrapped inside. Cool. Okay. Let's actually do print line, please. It's a real number. Not a real number, an actual number. And we continue. Okay, this cargo run. Please enter an actual number. Please enter an actual number. 2, you guess too small. 60, too big. 40, too small. 50, too small. 55, too small. 57, too small. 58, nice. Okay, that seems to work. What else do we have? Let's have we switch from an expect call to a match expression to move from crashing on an error to handling the error. Okay, yep. The pass is able to successfully, yep, will return okay, otherwise it will return error. Yeah, nice. Errors as values. The best version. For sure. Yeah, nice. I think we got this. Pretty cool. So far so good. Alright, our guessing game is kind of done. I wish I had the formatting working, but it doesn't seem to like it very much. Let's actually rustfmt install. There it is. Deprecated representation of it installed via rust up. Well, you kind of refuse to do so, so .rs on the guessing game. No, it's still not working. Okay, we can get rid of that. That's kind of annoying. It's not working, the formatting. Zig, it literally just worked. Like I could just save and it worked. I never have to touch anything. I just install the LSP. Okay. Let's continue. Number 3. Common programming concepts. Yeah. Okay. Oh, okay. Let's do a bit of theory. You guys ready for a little bit of theory? By default, variables are immutable. Yeah, I think it's a good design decision. This is one of the many nudges Rust gives you to write code in a way that takes advantage of safety and easy concurrency that Rust offers. However, you will have the option to make variables mutable. When a variable is immutable, once a value is bound to a name, you can't change that value. To illustrate that, generate a project called cargo new variables. Okay. Okay. There we are. It's funny, as soon as I saved, we got some stuff. Maybe it's probably Rust Analyzer stuff, but anyways. If we do this, we do first assignment to X. Consider making this binding mutable X. You cannot assign twice immutable values. Yeah, that makes sense. Compiler helps you find errors. Compiler errors can be frustrating, but really they only mean your program isn't safely doing what you want it to do. They do not mean that you're not a good programmer. Oh, thank you. Experienced crustaceans still get compiler errors. Bro, are we that soft that we need to be told this? Never at any point do I not think this. Okay, nice. It's a nice little encouragement. You know, there is the Rust dev versus C dev meme, like, you know the. So, I guess we're gonna need reassuring, boys. Where's the rest? Yeah. Right, unsafe all over the place. Rust carbon. Was it average Rust dev? You like using Linux, don't you? I have two sides sensitive femboy fox and rewrite it in Rust. No, bro. Okay, let's leave that before I do something I can't take back or something. That meme gives me Decipad flashbacks. Fair enough. Can't say much. Oh. How's everyone doing? How's chat? Is everyone still here? I bet. Have you all left? Let's check the stream. Where is the stream? Oh, it's behind here. Let's see on Twitch. How many viewers? Oh, I got a follow. Thank you, Dimitra. Wait, I can't see the viewers. View count. What did it put me in? Education. This is really the wrong game to be in. Yeah, no, this is not correct. Just realized. Edit stream info. Yeah, category is not whatever this is. Search category is software and game development. That's it. Okay, there we go. That's better. Can I only see viewers through here? 3. Okay. We know is odd exists. I actually kind of want to understand what the hell this is doing. Alright. Let's continue. Constants. Like immutable variable, constants are values that are bound to a name and are not allowed to be changed, but there are a few differences between constants and variables. Okay, interesting they exist. First, you aren't allowed to use mutable with constants. Constants aren't just immutable by default, they're always immutable. You declare constants using the const keyword instead of let keyword. And the type of the value must be annotated. We'll cover types and type annotations next section, so don't worry about that. Constants can be declared in any scope, including global scope, which makes them useful for values. The last difference is that constants may be set only to a constant expression, not the result. I wonder how they're in the stack. Is this just a define? You know, in C, is Rust const same as hash define? Define is pre-processing code that doesn't create. Should I use constant define? Let's see. No, what's the difference between define and const? Define directive uses no memory and is used by the preprocessor to manipulate the source code before compilation. Oh, it's it fills stuff in, right? Yeah, fills this. Yeah. All right, fair enough. Yeah, cool. Great. Shadowing. As you saw in Guessing Game tutorial in chapter 2, you can declare... Is there anything else? No. The same name as previous variables. Rustaceans say that the first variable is shadowed by the second. Excuse me, what? Okay, let's read this code. So we have let equals 5, let x equals x plus 1, let x equals x times 2. So wait, what's going to happen? So we're going to have 5, we're going to have 6, we're going to have 12. So 12, and then after we're going to have 6, 12 and 6, yeah. Shadowing is different from making a variable as mutable because we will get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let... Okay. Few transformations of the variable. Okay. The other difference between mutable and shadowing is that because we've effectively created a new variable when we use let keyword again, we can change the type of the value but reuse the same name. For example, say our program asks the user to show how many spaces they want. Wait, what? Oh, so yeah, you change the type. Okay, that's interesting. Why is this useful? This seems so error prone to me. This just doesn't seem great. Wait, where's the chat? Yeah, it doesn't seem great. Shadowing is different from making... Yeah, okay. Rust, why is shadowing useful? Allows for more flexibility in coding, allows to reuse variable names, allows type changes. Yeah, actually, what is this? Rust, it is encouraged to shadow value, but wait, doesn't the program already have a variable name guess? It does, but Rust allows you to change it. Whoa, this feature just introduced from like hard to follow code. Accessing variable. I have this information based on experience and following source 1, 2, 3, 4, 5. Does have advantages. Yeah. Oh yeah, I actually just didn't follow the tutorial on this. What's a convenience to, yeah, take advantage of this? Because it was initially supported and never removed. Nice. No. Okay. It's more like we never forbade shadowing since it fell out of the implementation of the compiler. Since it just fell out of the implementation of the compiler. Alright, so like the way you implement the compiler allowed for this to happen. As I recall, Grade and floated the idea of forbidding shadow, but I stuck for the feature nobody else really cared, and so it stayed. Okay, so because someone made it and Rust is backwards compatible, I think that's their whole thing. They're never going to have a breaking change that will not compile code. Okay, fine. Okay, let's continue. Data types. Yep. Shows in the person who roll this way following error. This must be none at this point. Cannot satisfy this. This. This is cool. This is really, really cool, actually. Using the type system. Like, yeah, this is cool. I like it. So we got your scalar types. They represent a single value. There are 4 scalar types: integers, floating point numbers, booleans, and characters. You may recognize them from other programming languages. Just jump into them. So we have integer types. All right, your standards. You have your architecture sizes. You have your bits. Yeah, nice. And 2 column representations. That's pretty standard. Yep. Additionally, these are architectures. Yeah, architecture sizes. Nice. You can write integer literals in any form. And note that number literals that can have multiple subsections. 57U8 to designate the type. Number literals can also have an underscore as a visual separator. Okay. Nice, nice. Binary there, yep. Integer, let's say you have a variable U8 that can hold values between 0 and 255. If you try to change the value to outside that range, such as 256, you get integer overflow, which can result in unrecoverable error. When you're compiling in release mode, Rust does not include checks for integer overflow that cause panic. Instead, if overflow occurs, Rust performs 2's complement wrapping in short values greater than the max wrap around. Okay, so in debug mode, Rust will panic and will tell you to, you know, get your grip together. But release mode, they wrap. Yeah, it's better than panicking, I suppose. To explicitly handle the possibility of flow, you can use these families of methods provided by the standard library. Wrap in all modes with wrapping underscore add. Return the none value if there is overflow with checked methods. Returns the value and boolean including overflowing. Okay, makes sense. So we have protection against overflow or just crashes in development, which is, yeah, this is nice. I get it. Floating points with a dot. Numeric operations, yeah, pretty standard. Boolean types. And then chars. Okay. Note that we specify char literals with single quotes as opposed to string literals which use doubles. Good point. What is what's going on? Equals hello. What are you? You are pointed to a string. Pointed to a string, and you string slices. See also standard string. A string type, also called string slice, is the most primitive string type. It is usually, yep, static string. Yeah. So, but you are literally just an array of U8s, right? But just wrapped nicely. Okay, I hope so. Component types, tuple. Oh, nice. I didn't know this was a thing. But cool. Yeah. Nice. Yeah. Tuples are useful. x.0, x.1, x.2. Okay. Array types. Nice. Yep. Oh, so you can find... You can write an arrays type using square brackets with a type at each element. Okay. That's cool. You can also initialize an array to contain the same value for each element by specifying the initial value followed by a semicolon, then the length of that array. Okay, so 3 5s. No, 5 3s. Yeah, other way around. Nice, nice. Ah, nice. Oh yeah, and then the panic here. If you do an array access that's out of bounds, it returns a runtime error at this point using an invalid value in the indexing operation. The program exits an error message didn't execute the final print line statement. When you attempt to access an array using indexes, Rust will check that the index provided is less than the array length. So yeah, it inserts this little check from what I understand. If the index is greater than or equal to the length, Rust will panic. This check has to happen at runtime, especially in this case because the compiler can't possibly know what the user will enter. This is an example of Rust memory safety principles in action. In many low-level languages, this kind of check is not done. When you provide an incorrect index, invalid memory can be accessed. Rust protects you against this. That also makes stuff quite slow, I would say. But anyways, that's probably for someone more experienced to talk about. We got some functions. We got some parameters. Okay. We got some statements. Oh, what is this? This code does not compile. Function definitions of statement. The entire preceding statement is itself. A statement is in itself. Yet statements do not return values. Therefore, you can't assign a let statement to another variable. So let y equals 6 doesn't return anything, so it doesn't, do this. Only support it directly if there's an if or while. Okay. So there isn't anything exclamated. This is different from what happens in the language that C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals 6, and you have x and y have the same value, but not in Rust. Expressions evaluate to a value make up most of the rest of the code that you'll write in Rust. Consider a math operation as 5 plus 6, which is the expression that evaluates to the value 11. Expressions can be part of the statement in listing 3.1. And 6 statement, y equals 6 is an expression that evaluates to 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly braces is an expression, for example. This. Ooh, implicit return then on the x plus 1. So this is 4, right? In this block, in this case, evaluates to 4. The value gets bound to y as part of the let statement. Note that x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of the expression, you turn it into a statement, and it will not return a value. Interesting. So expressions do not include ending semicolons. If you add a semicolon to an expression, you turn it into a statement, right? This is a statement, this is an expression, this whole thing is an expression. So expressions contain statements and expressions and kind of recursively on and on. Yeah, that's quite cool to fully understand the anatomy of a program. Functions with return values. Functions can return values to the code that calls them. We don't name return values, but we declare their type with an arrow. We return valid function is synonymous with the value of the final expression in the block. Lovely, look at that. Yeah, just plump 5 in there. You can return early from this using 5. Most functions return the last expression implicitly. I don't know. It seems weird. Seems cool, but it seems like it would make the code a bit hard to understand sometimes. There are no function call maxes or even let statements in the 5 function. Just the number 5 by itself. That's perfectly valid function in Rust. Note that the function's return type is specified too. Okay. The 5 in find this function's value, which is why the return type is i32. Let's examine in more detail. There are 2 important bits. First, the first line. Yeah. Yep. I mean, yeah, looks good to me. This produces an error. Okay, let's check why. So we have function x plus 1 5 y expected I32. Implicit return and its body has no tail or return expression. Oh, because of the semicolon. Yeah, never mind. Didn't see that. Okay, but you can just return, right? You can just go. But I can just do this, and then this, and then this does the, yeah, okay, of course. Okay. Nice. Comments. Nope. Wait, actually maybe. Comment. Okay, that was useful. Can you do multi-line comments? Is that a thing? Yeah, you can. Lovely. Cool. It's all nice. We have if statements. They do not need. I like that they don't need brackets either side. Golang does that, and I don't know. I just think it looks cleaner. Yep. If number, does this crash? This should crash, right? Yeah. Good. No JavaScript. Funny business here. Yeah, if else. Okay, yeah, this kind of stuff. Everything expressions you can assign. Expressions is quite similar to Zig, or Zig is quite similar to this. You know, never quite know. Nice. So yeah, little expression, not a statement. This is also an expression. 5 is an expression. This is a statement. A statement's not return. This is an expression and it returns. The 6 itself is also an expression. Would be nice to see an ASD of this. This crashes though, right? It's mismatched types, yeah. Repetition with loops. So we have loop, while, and for. I love loop. I love regular loop. I'm glad this is actually part of the language. I love doing stuff like while true, or just for in Golang and stuff, and breaking out in specific cases. It's just, yeah, it's just cool. We can also use continue. Yeah, okay. Returning value from loops. Oh, okay. So we have an expression here with a mutable counter. We go around. If count is 10, we break and we times by 2. So we break, we return a value from this, and we place that value as the return value of the expression. Pretty cool. Very nice, very nice. Oh wait, where am I? I feel like I just jumped. Okay. Labels. Why is there a little thing here? Let's make cargo new control underscore flow. cd control flow. Control flow this. Do I need that? Wow, I actually do. I need that little semicolon. Not sure why. Seems weird that you need it, but anyways, you do a loop. You do a count, print. You do another loop in here, and we do if remaining is 9. If count is 2, we go counting up. Okay, let's just run this in our heads, see what happens. So we enter the loop. We get remaining is 10. We loop, then remaining is 10. If remaining is 9, we break. If count is 2, we break up there. There's no value assigned, so that's fine. So remaining minus equal 1. Now it is. Now we break. We go up. We continue assigning it. Yeah. Cool. Yeah, remaining. So it prints. Count at the very top. 10, 9. And if it's 9, it breaks, and then it increases the count. Yeah. Cool. Yeah, while loops. Looping through a collection with 4. 4 element in A. A more concise, yeah, alternative is the 4, yeah. So this so the 4 takes in a trait. What's the trait? I don't know what the trait is, but like it would be like an iterator trait. Goes a bit nicer, isn't it? Yeah, nice. Okay. Okay, 1, 2, and 3 done, and now we're going into some ownership. This is like the whole thing with Rust, isn't it? Okay, let's check the stream. How's everybody doing? Still haven't really figured out this Twitch studio, to be fair. We got some kind of want to, you know, see the number of views I have. Oh, it says up there 2. I am stupid, sorry. 2 viewers. Ooh, ownership. Knock 7 C 9. Ooh, who are you? Don't know you. Oh, maybe I do. I don't recognize your nickname. Just knock works. Knock. Yeah, hello knock. Do I know you? You just found the stream randomly? Nah, new here. How's it going, mate? Fair enough. Yeah, going all right. Trying to get through this book, through this Rust book. Getting to know as much as possible for a couple of projects. Yeah, cool. Yeah, welcome. Hope you enjoy the stream. Hopefully, I'll do a couple more of these. Enjoying it so far. Actually, it's very different from making videos. It feels more involved, even if there's no one watching. It's quite cool. Yeah, welcome. Knock. You can follow me on GitHub, on YouTube as well. I think the links are below. You make videos, YouTube. Yeah, they should. I'm not sure if they're on the stream. Below, on the links. How do I even go to my own stream? That's a good question. Yeah, they should be below, right? If not, I can go on YouTube/channels. It's this one. I'll post it on the chat.
We need to do inputs
yeah,
for each line.
I'll put it on the chat. There you go.
Forgot about that. So it's for each line.
Yeah, there are a couple of programming videos and a couple of other interesting videos. So I did a bunch of Golang videos recently about a project, like an ASD Golang project, where I try and parse the Golang code to extract the struct types and generate some specific TypeScript code, not just TypeScript, but like validator code, like Zod or Valibot that I was using. And the point is that eventually I can make this for like various validators. So if you need to do like an HTTP request from Golang to the browser, you can validate your code, right? If you know the rule with type systems, you should pass, not punt. I can't remember the thing. You should always check for your type instead of guessing the type. Ooh, Gopher, you're like my arch enemy or something. How so? Don't like Go? Go's pretty cool. Very nice, super easy language. Very, very cozy, I would say, and very performant. It's like a language I would really use if I needed to do like team project. I'm a Rust dev. I think we're supposed to hate each other. Nah, bro. Nah. No need for that. Just use whatever you like. I like Go sometimes. There's also a bunch of Zig. Like I did not the entirety of the advent of code. I'm still pushing through a couple. But I did a lot of the advent of code last year, 2023, in Zig. Yeah, that was really fun. A lot of these videos are really long. But yeah, that was a lot of fun. Maybe this year I'll do it in Rust. Not sure. If you go far back, this is ages ago, 6 years. Did a couple of guitar videos. 3 years ago, did another guitar video. Couple of more random videos. Huffman encoding in Zig. There's also a parser that I wrote in Go. That was quite a fun project. Did it last year in the summer. Around there. If you want to check it out, I'd really appreciate it. Let me know what you think as well. Let's see. Yeah, I'm trying to learn Go, to be honest. I did a bit and lost a bit of interest. Gotta get back to it. Not gonna lie, I'm not a fan, but I love the runtime. Runtime is sick, isn't it? It's really cool. Yeah, Go is interesting because it's so simple, and like I can probably teach someone Go in like 20 minutes, right? If they're a programmer, just 20 minutes, you're up to speed with Golang. It's just too simple, huh? Yeah, that is like the criticism people give. Like the types are very simplistic, the control flow quite simplistic. Even enums suck in Go. There are no enums in Go really. They're just constants, which pretty sucks. But the beauty of Go is that it is simple, right? Like it's so simple and still performant and safe-ish, I would say. So if you need to make something that's very maintainable by a bunch of people, it's quite a good choice, I'd say. Also, the standard lib for Go is amazing, incredible. Golang people really just don't like installing packages, and for good reason, because the standard lib just works so much. Indeed, it makes sense for a workplace. Yeah, for sure. Yeah, you're right. It's not the most exciting of languages, but I think that's exactly why it makes it good for a workplace. Yeah, it's like simple and get everyone up to speed, and the standard lib just is great. But I do wish they would kind of sort some of the stuff out. I just want enums. I think if they add proper enums to Golang, I'll be happy. Everything else can probably stay, but enums, yeah, not good. Where are we? Okay. Let's continue. Ownership. How does this work? Oh no, it's so much text. Okay. Ownership is a set of rules that governs how a Rust program manages memory. All programs have to manage the way they use computer memory while running. Some languages have garbage collectors. In other languages, the program must explicitly allocate in free memory. Rust uses the third approach. Yeah, I was really interested about this because I know you don't actually allocate memory in Rust as you do in stuff like Zig or C. And obviously it's not garbage collector like Go. If any of the rules violated, the program won't compile. Through a system of ownership with a set of rules that the compiler checks. Yeah, I mean, it's very cool. I wonder what the limits are. Yeah. Okay, none of the features of ownership will slow down your program while it's running. Yeah, this is very nice. What do we have? Yeah, ADTs are dope. Can't live without them. ADT. What's an ADT? Am I ADT programming? Oh, abstract data type. Yeah, of course. Right. Cool. The stack and the heap. I think I'm going to skip this because I kind of understand this. So basically, summarizing for anyone in the chat, the stack is very fast because it doesn't really need to ask the operating system for more memory. The heap is slower, but much bigger, because but it's slower because it needs to ask the operating system for memory to have some assignments. The stack takes care of its own freeing and stuff, because as soon as you exit a scope or a function, like the stack is popped and that variable disappears. However, the heap is very different because you can allocate, and you exit scopes, it's still allocated. Or in garbage collector languages, the way you would know to free something from the heap is keeping account of references, right? So if a variable, if something that's allocated in the heap is kind of lost, like there's no more visible references to it, then it's safe to garbage collect because no one else will ever use it. There's no there's no rest. But that process of counting references and then eventually collecting the memory, and kind of sometimes unpredictably collecting the memory, slows your program down. The main trade-off is that the set of valid Rust programs is a subset of all valid programs. Yeah, this is it's kind of what I had in mind. So you have to use unsafe sometimes to kind of tell Rust to allow weird ownership formats. Is that why? Like, yeah, you're gonna have to have unsafe because of this limitation. You have a subset of all valid programs. Yeah. Unsafe means trust me, bro. Yeah. So you need a couple of trust me bros on your program. Fair enough. Okay. Yeah, exactly. So this allocator never has to search for place, but yeah. Okay. Anyways, ownership rules. Let's have a look at the rules. Each value in Rust has an owner. There can only be one owner at one time. When the owner goes out of scope, the value will be dropped. Okay, seems sensible. Now that we're past basic Rust syntax, we can include all the function main code in examples. So we won't include. Oh right, we won't include. Yeah, cool. At first, so we have let s equals hello. The variable s refers to a string literal. Okay, s is not valid here. It's not yet declared. So before the scope, it's declared here. Do stuff with s. The scope is now over, and s is no longer valid. In other words, there are two important points in time here. When s is in scope and it is valid, when it's out of scope. At this point, the relationship between the scope and when variables are valid is similar to that in other programming languages. Now we'll build on top of that the string type. To illustrate the rules of ownership, we need a data type that is more complex than those we covered in data types. Okay, so the types covered actually, hold on one sec, just checking my phone. Okay, let's keep going. The types covered previously had a known size and can be stored on the stack and popped off the stack when the scope is over. Yeah, they're pretty trivial, but we want to look at data stored on the heap and explore how Rust cleans up data in the string type, for example. Yeah, this is kind of one of the things I don't love about this language, I would say, because if you wanted a string in Zig, you always pass an allocator, so there is never hidden allocation. So let me go to the admin of code where I did Zig the entire time, and I'll show you any of the days. So I have solve here. Just change that to const. I still get some. LSP is telling me some errors. Oh, what the hell? My Neovim just crashed. That's not great. Nice, gotta love that. Okay, still gonna go here. Day 13. So you have this concept of an allocator. So I guess Rust lets Rust handle memory. Zig lets you handle memory all the time. So every time you need to allocate anything, you create an allocator and you pass it to functions that will require you to allocate memory. I mean, you could allocate an allocator inside a function, or you could dependency inject the allocator so that you up here can kind of control the type of allocation that goes on in place. You can have a general purpose allocator, an unsafe allocator. You can have even a stack allocator that does a buffer on the stack instead of heaps. It's very cool. It's a good concept because now you can just use this allocator. And yeah, and another really good example of this. Who do we have? Do I think I'd stick to just passing? Then I think I'd get sick of passing allocators everywhere. Yeah, that is kind of. To be honest, it's not really that much of a problem once you get used to it. Let me show you Huffman's, which is Huffman encoding I did. So you have this concept of a heap because you need a heap structure. So you create. This is kind of Zig's macros. There's no macros in Zig, but you have comp time concept, which is really cool. So this is, the type is evaluated at comp time. This is a generic, right? You evaluate the generic at runtime and you return this. And in this struct, you put an allocator in. So when you initialize the struct, you call this init function. The allocator then actually allocates your memory, and you have a D in it that does self.allocator.free. The cool thing about this is now this struct can allocate its own memory whenever it needs to, but it will always do so through the initialized allocator that you passed in. So really, you are at the top free to control the memory inside of this struct, and the struct can kind of be independent of that and just have a generic interface for allocation, but you can decide what the strat of allocation is, which is a very cool concept. Yeah. Anyways, back to Rust. String types. Yeah, I mean, there's different ways of doing things. I need to learn more about this one so that I can, make my mind up. Not that one is better than the other, I'd say. It's just different and better in certain circumstances, or something. Okay. One reason that, okay, let's see. We've already seen string literals where a string value is hard-coded into the program. String literals are convenient, but they aren't suitable for illustration that you want text because they are immutable, yeah. The Rust has a second string type, string. This type manages data allocation on a heap, and as such is able to store an amount of text that is unknown to us at compile time. You can create a string from a string literal using from function. Like so, string from hello. The double colon operator allows you to use a namespace. Yeah, this is cool. I like this. This namespacing, really sick. Okay, we have a namespace, and then we get the from function under the string type rather than using some sort of name like string underscore from. We'll discuss the syntax method and method syntax later. Namespace must win paths for referencing to an item in modular tree. Yeah, I'm excited about this. Hopefully we have time to get there. I'll probably have to go in like 2 hours. 2 hours? Hour and a bit actually. Okay. So let's create a mutable string, hello. We push to the string hello, and we print. Okay, so what's the difference? Why can't string be mutated, but literals cannot? Well, it's because of heap allocation, right? Like, yeah. In case of a string literal, we know the contents at compile time, but text is hard-coded directly into the final executable. This is why string literals are fast and efficient, but their properties can only be, So you know what they are beforehand, so you can be very smart about placing them in specific, putting them in specific parts of the stack. Unfortunately, and even registers, right? You can be very smart about which registers they go to, and you can align cache properly. Yeah, a lot of different stuff that makes this very fast. Okay, with the string type, in order to support mutability growable piece of text, we need to allocate an amount of memory on the heap unknown at compile time to hold the contents. This means the memory must be requested from the memory allocator at runtime. We need a way of returning this memory to the allocator when we're done. Yeah, so Zig would let you handle this, but I guess Rust does it for you, which is nice. The first part is done for us. When we call string from, its implementation requests the memory it needs. This is pretty much universal in programming languages. Wait, its implementation requests the memory it needs. Yeah, fair enough. However, the second part is different. In languages with a garbage collector, the GC keeps track and cleans up memory that isn't being used anymore, and we don't need to think about it. In most languages without a garbage collector, it's our responsibility to identify when memory is no longer being used. And to call code explicitly to free it, just as we did to request it. Doing this correctly has historically been a difficult problem to solve. Yeah, that's true. If we forget, we'll waste memory. If we do it too early, we'll have invalid variables. If we do it twice, that's a bug too. We need to, double free problem. Yeah, we need to pair exactly one, allocate with exactly one free. Yeah, this is very true, and I think we have a lot of new languages that try and solve this problem. The fact that malloc and free is just difficult to keep track of. You need we almost need like a static analyzer to make sure that you're doing things all right. Rust takes a different path. The memory is automatically return once the variable that owns it goes out of scope. Here's a version of our scope complete. Yeah, so okay, this variable is now over s. Okay, so we call a free at the very end. So it's like defer. So like we defer the free, but we don't have to say it, which is pretty cool. Okay. There is a natural point at which we can return the memory our string is. Yeah, okay. Rust calls a specific function for us. The function is called drop. The destructor of the type, yeah. Okay, like the init, yeah. And it's where the author of the string can put the code to return the memory. Oh, yeah, whoever, yeah, okay. Rust calls drop automatically at the closing brace. Cool. This pattern has profound impact on the way Rust code is written. It may seem simple right now, but the behavior of the code can be expected. Yeah. Variables and data into interaction with move. Multiple variables can be interact with the same data in different ways in Rust. Okay, so we have x equals 5, y equals 5. Okay. You can probably guess what this is doing. Bind the value 5 to x, then make a copy of the value to x and bind it to y. We now have two variables x and y, and they're both equal to 5. This is indeed what is happening because the integer simple value is unknown, fixed size, and there are two 5s pushed onto the stack. If we do this, this looks very similar. We might assume that it's the same, but isn't. So a pointer, I guess. Take a look at this. See what's happening to the string of the hood. A string is made up of 3 parts, shown on the left. So we have a pointer, a length, and a capacity. To the memory that holds content, length and capacity. This group of data is stored on the stack. On the right is the memory on the heap that holds the content. The pointer points to the index, and then yeah, there we go. Very, very straightforward. I guess an array on the stack, on the heap. Sorry. The length is how much memory in bytes the contents of strings are currently using. When we assign so okay, you're teaching me about pointers, right? The representation does not look like 4.4-3, which is what memory would look like if Rust instead copied the heap data as well. If Rust did this, the operation s2 equals s1 could be very expensive in terms of runtime performance. Yeah, true. Earlier we said that when a variable goes out of scope, Rust already calls the drop function and cleans up the heap, but figure 4-3 shows both data pointers point to the same location. This is a problem when s2 and s1 go out of scope. They will both try and free the same memory. This is known as the double free error, and is one of the memory safety bugs we mentioned earlier. Freeing memory twice can lead to memory corruption. Yep. To ensure memory safety after the line let s2 equals s1, Rust considers s1 as no longer valid. Therefore, Rust does not need to free anything when s1 goes out of scope. Check out this. Wait, okay. We do this, we do this, we do this. You'll get an error like this because Rust prevents you from using the invalid references. I'm not sure I get it. Let's try. Let's write this. Cargo new ownership. Does this not run? Okay, let the else be. Move occurs because s1 has type string, which does not implement the copy trait. Consider cloning the value. Borrow of move value s1. Yeah. Okay, this is nice. The LSP is super helpful. This is really, really nice LSP. And if I run, yeah. Move occurs because s1 has the type string, which does not implement the copy trait. Value was moved to s2. Value borrowed here after the move. But if I do s2, it all disappears. So the ownership of s1 goes to s2, and then wow. So I'm guessing then if I do a scope s2, then I can do print line s1 world, and I do. Actually, I can probably just do s1 here, right? Or no, I think maybe it needs a bit of help. Wait, no, surely this works. No, because it was borrowed into there. Borrow of moves value, but But yeah, it's a different scope though, no? Why doesn't this work? Let's have a look. It's all trade-offs for sure. Rust errors. So knock, why does this not work? I'll keep you in the chat here, to the left of the program. S2 is dropped at the end of the scope. Oh, it's freed. Right. Yeah. No. So the ownership of string completely moves to S2, and then it's freed at the end of the scope. It's not just the reference that's dropped. The entire memory is dropped. Is that right? Do I understand this correctly? It's not a ref. It's not a ref to S1, which then points. Change S1 to pointer. Oh, you mean S2? Or you mean here? Oh, let S2 equals the pointer to S1. Right, now it's a reference to S1, which then references the heap. The rest completely transfers stuff over. Right. Right, I understand. Really cool, thank you. Right. Okay, nice. Oh. Dog is barking. Right, let's put you back here. Okay. Oh my god. The dog is just barking at the door like crazy. I don't know if you can hear it, but really going for it. Just one sec. All right. Okay, got it. That's very cool. But yeah, we can then do a clone that does actually copy stuff over. Stack only data copy. There's another wrinkle we haven't talked about yet. The code using integers. But this code seems to contradict what we just learned when we don't call this. Yeah, but this is because they're scalar values, so this makes sense, right? Rust has they implement copy trait that we can place on types that are stored on the stack as integers. We'll talk more about traits in chapter 10. If a type implements the copy trait, variables that use it do not move, but rather are trivially copied. Rust won't let us annotate a type with copy if the type of any its part has implemented the drop trait. Okay. So these are conflicting. Interesting. If the type needs something special to happen when the value goes out of scope, we can add the copy annotation to that type. We'll get a compile time error. Interesting. Very cool. Okay, so yeah, basically like scalar values let you just trivial copies. Oh, and then tuple types as well. Ownership and functions. The mechanism of passing a value to a function is similar to those when you assign. Oh, okay, so yeah, the ownership. So we take S. S owns the string. We take ownership in the function. S's value moves into the function, so is no longer valid here. So, okay, takes ownership, some string. We print the string here, substring goes out of value, and drop is called. The backing memory is freed. So it's as if S no longer exists. So yeah, if I try to use S at any point, makes sense. I'm actually going to copy this. I want to see if you complain when I do. Yeah, what happens if I do like print line S? Yeah, borrow. Okay, good. The LSP complains, and then the compiler complains. So I'm okay with this. Borrow of moved value. Yeah. So okay. Interesting. I need to play with this more to see if I actually like it. Still, I think it's a cool concept, and it probably works for large programs, right? You have to be very careful about what owns what, otherwise your stuff won't compile. Yeah, okay, makes sense. Return value and scope. So if we do S1 that gives ownership, so we initialize a string here, and then we pass it to some string. No, sorry, we return it from here. Some string is returned and moved out to the calling function. So now S1 owns it. So then we have S2 that comes into scope, takes and gives back. Okay, I see. So then, yeah, it borrows the value and then it gives back the ownership to S3. Oh, and then this is where I could shadow the value, right? If I do let S2 equals this. Yeah. Okay, let me try that. Maybe that's why shadowing is kind of interesting. If I do S2, yeah, this now just works. Cool. Interesting. All right. Cool. What else do we have? The ownership of a variable follows the same pattern every time. Assigned to a variable, variable. Assigned to another variable moves it when a variable that includes data on the heap goes out of scope. The value will be cleaned up by drop unless ownership of the data has been moved to another variable. While this works, taking ownership and then returning ownership with every function is a bit tedious. What if we want to let a function use a value but not take ownership? Yeah, this is my next question. It's quite annoying that anything we pass in also needs to be passed back. If we want to use it again, in addition to any data resulting from the body of the function that might want to return, Rust does let us return multiple values using a tuple. So we have S1, and we calculate the length, giving to S2 and then the length. But this is too much ceremony and a lot of work for a concept that should be common. Luckily for us, Rust has a feature for using a value without transferring ownership called references. I mean pointers. Oh, borrowing. Right. Okay. It's a lot of theory going on. Let's see. Yep. Borka really goes nuts. Nice. It works for sure, but trade-offs. Lul. True. Where are we? Okay, let's keep going. Chapter 4. How many do we have? A few. 20. And they get harder and harder. Okay. Anyways, let's just keep going. I think I'm going to read this chapter. And then I want to solve some advent of code with it. Otherwise, I'm going to die of boredom. Okay. We have this. We have the length. It's calculated. We can pass in a reference. Yeah. So yeah, we pass in S, which is a pointer to S1. That makes sense. Yeah. Let's take a close look at this function call. The ampersand S1 syntax lets us create a reference to that refers to the value of S1 but does not own it. Because it does not own it, the value it points to will not be dropped. Only the reference itself will be dropped. Not dropped, it's a stack variable. So likewise, the signature of the function uses that to say it's a pointer. The scope in which the variable S is valid is the same as any function parameter scope, but the value pointed to by the reference is not dropped when S is dropped being used because S doesn't have ownership. Yes. We call the action of creating a reference borrowing. Really? You have to. That's all borrowing is. Okay. Does that mean? What does that mean? That means you. Okay. Oh, but you can't actually change it. Attempting to modify a borrowed value. Okay. Okay, that. Oh, wow. Okay. What if I do want to modify a borrowed value? Do I have to consider changing this to a mutable reference? Okay. Okay, nice. I see. Mutable references, and then this works. Yep. But if we try and have two pointers, then we cannot borrow S as a mutable more than once at a time. Makes sense, makes sense. There, Sarah says this code is invalid because we cannot borrow S a few times. The restriction prevents multiple mutable references to the same data type, in a very controllable fashion. It's something that the new restations struggle with because most variables let you mutate whenever you'd like. The benefit of having restrictions that Rust can prevent data races at compile time. A data race is similar to a race condition and happens when you have 3 waves of code. 2 or more pointers access the same data at the same time. At least one of the pointers is being used to write the data. There's no mechanism to syncing. As always, you can use curly braces to create a new scope, allowing to multiple references. Yeah, cool. No problem, no problem, big problem. Right. Oh wait, you can't use this. Oh, right, so you can only have... Rust enforces a similar rule for combining mutable and mutable references. Code results in an error. Immutable borrow later used here. Cool. Few. We also cannot have mutable references while we have a will not be used after this point. Wait, how is this allowed? Note that a preference scope starts when it is continue less than blah blah blah. Wait, this the scope of the immutable reference R1 and R2 ends after print line where they are last used. Oh, right, so they have to be referenced below. Then dangly references, okay. In languages with pointers, it's easy to erroneously create a dangling pointer, a pointer that references location memory that's been freed. Yeah. So we have let reference to nothing dangle, we do this and we point it, and then S will go out of scope and be freed, be dropped, or even. Missing lifetime specifier. Yeah, this is, let's see. Okay, let's take a closer look at exactly what's happening. Yeah, I mean, I understand. S is going to be freed as soon as you exit this. Because S is created inside dangle, when the code dangle S is deallocated, but yeah. The solution here is to return the slice directly instead of a pointer to said slice. Okay, the rules of references, let's recap. You can have either one mutable reference or any number of immutable references. The references must always be valid. Then we have the slice type. Yeah, I'm probably going to need this, but I'm not going to read this right now. Let's check chat. You know, you might be better served doing the Rust links than skimming the book after, since you know how to code pretty well already. Can I post links? Yeah, I think so. Right? I think you can post links. No. Oh, is this the... I think I've heard of this. This is the... Like the examples, isn't it? Rustlings, watch for if I run. Pretty cool. This is interesting. I'm going to save this. I'm going to come back to it. Because I really want to do admin of code. Let's try day 1. So basically, I'm gonna have to do a little bit of I/O. It's gonna be nice. Okay. Yeah, I think that's okay. Let's go cargo new ASC. ASC, that's main Rust. Let's do input.txt. All right. Let's chat. Yeah. Rust, read file line by line. Read underscore lines. This comes from... What is this? Wait, this is not a naive... Just don't... How do I read a file line by line? So we do file, opened, buffered reader, we read, and then for lines, okay. Okay, that seems fine. So, that file equals, is it file that uses namespace read a immutable string, so /input. Is that good? What's up with the question mark? Type differ immutability. Why doesn't it like this? File open, that's file read. File open takes in just p. Okay. We'll come back to that. Let reader equals buffered. What did I call it? Buff reader. This is namespace read. Is it read line or just new? We take in from file. Okay, and then we go for line in reader dot. What was it? Reader dot lines. Why doesn't it like that? Doesn't seem to like that. What's going on here? Does it not know? It doesn't seem to understand. So it knows you're a buffered reader of a file, but I can't do lines. Buff reader. Lines? Lines is a function. Yeah, but it's not coming up on the LSP. Question mark is the go if air stuff. Oh, does it throw it upwards, returning result? You can replace it with dot unwrap instead. Oh, cool. Right, got you. Unwrap and then it panics if there's an error. Right, I understand. Lines is a function. Yeah, but there's no method called lines apparently. Bruh equals reader dot lines. No, there's no. Okay. What is this? Required by a bound introduced to this call. The trait bound. Do I have to do dots unwrap? No. I'm so confused by this answer on Stack Overflow. Rust read file line by line. Actually, let's do Rust AOC solutions because this will definitely give me correct numbers. So let's do. Oh, they don't have 23. Let's just go here. No, let's go here. Day 1. This will probably be on utils or something, right? So let's check this out. Solver.solve. Yeah, it takes in self. Oh, this is a macro. They have their own little macro configured. All right, chat, what's going on? Lines is from a trait, I forget which. Add use this to the top. I thought it was buff read instead of buff reader. Oh, is that where I went wrong? It's buff read. Where are we? Reader, buffered reader. Yeah, so yeah, this is an interface. So lines from what's this take in self returns an iterator for the lines of this. So does buff reader return from file, and we can do dot buffer no. Required by a bound introduced by this call. The trait bound result file is not. So something is not set. Oh. So I have to unwrap up there. In our reader. Oh, okay. So I have to unwrap on the file open. And our lines appears. Okay, because it. Yeah. Got it. Yeah, I had to unwrap file open there. Or do an expect. Nice. So that's going to throw if anything goes wrong. And I guess I can just do print line, line, or actually prefer this syntax. Oh, really? What are we talking about? Line.unwrap. Do I have to do unwrap each time? I guess. So why does it can actually result in an error? Anyways, cargo run. It panicked. No. This is file directory. Oh, right, because I have to. Yeah, depends on where I'm running this. Great. It's really fast. Both compiling and printing. Pretty cool. Oh, this is really a bad. The puzzle I chose is really actually kind of a weird one. The hardest day one I've seen. Let's actually start with the example so that we can make sure we have this right. So we need to find, what do I remember? The newly improved calibration documents consist of each line of text. Each line originally contained a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and last digit in that order. So 1 and 2, 3 and 8. So we go forwards and then we have to go backwards through the line to find a value. Okay. So, can I do let line equals line.unwrap? Is it valid? Nice. And I can go through the line for C in line dot. Does this work? What's C? C. String as in string C item. I wonder if print line. See, string is not an iterator. Is there a way to iterate over a string? Chars. C is a char. Okay, cool. Ooh, can I do? I want to get fancy. So like, let first number equals. This is kind of weird. I wonder if it works. I'm trying to understand this language. So, and we go. If C is bigger than or equal to 0 and C is less than or equal to 9, we do C. No, is this too much to ask? Like, I want to like return C. Break C. Something like that. And buffer reader is an actual struct. Yeah, okay, and trait has to be scoped to use its methods. Yeah. Yeah, it was about an error. It was I wasn't doing the unwrap, and then that's why it wasn't working. Alright, let's get rid of this weird stuff. Come back to it. Let first number equals 0. Let mutable first number equals 0. And then here we do first number equals C dot. I need to parse. Rust char to ints. C dot 2 digits dot unwrap. 2 digits. The radius is 10 dots unwrap, and then the thing here now I'm gonna have to do is u32 instead. You can't break with a value in a 4. Use break on its own without a value. What is this talking about? It feels like it knows what it wants, so. Extract and throw, replace if with magic. Okay, let's do this. Well, no, that just looks worse. Can you go away? The value assigned to first number is never read. Oh, okay. Yeah, that there. And I guess we can break. So we don't need this anymore. Let's do the same. This is obviously like very inefficient. Can I do line dot reverse dot chars? Additional 0. What is this? Method reverse modify this receiver in place. It's available on no method named chars found. Oh, I have to do a dot unwrap or something. No. What do I have here? Try into. Like, what are you? Reverse. Oh, returns it in place. Okay, so I can do like line dot reverse. It doesn't actually return a value. And I can do line dot chars. And we go first to second underscore. Whoa, 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 cannot borrow line as mutable. What is, okay. And at the end we would be like print line. Number, we go. First number, second number. What is this? Cannot mutate immutable line. Ah, there you are. So it gave me 11, even after reversing. Let's just do line, see what happens. It ain't reversing. It doesn't seem to reverse. Reverses capacity for at least a digit. Is this not? Rust reverse string. Feels like it's not doing what I want it to do. Charles.rev.collect. Really? Okay. So I go. So I don't do that there, but I would do lines.chars. Oh, because chars isn't like an iterate, like an array. .rev, and I can leave it like that, and I don't need mutable because it does a copy there. I'm assuming. Okay. Good. What did the admin of code want? Okay, so the addition of the values. Let's mutable sum of u32 equals 0. The sum plus or equal to first number times 10 plus second number. We go print line part 1 the sum there 142. Cool. What's going on here? Okay. You need a label loop labeled for then break label. Actually, I'm not sure if it works with a for loop. Actually, never mind me. You don't need a label. It's very late over here. Oh, where do you live? Where are you from, Knock? Okay, so if it's late for you, like somewhere in Asia, Australia, they'd be asleep now. Oh, Australia. Yeah, fair enough. 11. Oh yeah, that is late. Fair enough. Cool. Nice one. Okay. I mean, looks fine, I guess. The second part is actually kind of difficult. So you need regexes but without overlaps. Oh no, with overlaps? Oh, I can't actually remember. I remember struggling with this though. This one being really annoying because you have to actually get 1, 2, 3, 4, 5, 7, 8. But the main problem I found this when I was doing this, you can have was it 9? Oh, I can't think of it. 9, 3. Yeah, let's go with that. 8, 3. They actually overlap. 8. Yeah. So this one was kind of annoying. I remember. But I need regexes now. So not only do I need this, I actually need a regex. Get with this information, you'd find a real first number. Yeah, okay. Rust regex. Where's this door? Oh, it just finds it's a regex. Let's actually remind ourselves. So if we have A3 and we want 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, no 0. Yes. So we do a match here. Regex match overlapping strings. How do you match overlapping strings with regex? Find all does not yield overlapping values by default. So I need some canonical for overlapping. Yeah. There's quite a few highly recursive topic. How can I match overlapping strings with references? You can't do this with regex alone, but you can get pretty close. Okay. So I guess we could really? Can't do this with regex alone. I guess I could shift. I could kind of do a starting point that's different. Really, regex isn't in the standard lib? It's like the same with random is not in the standard lib. It's kind of, okay, underwhelming what the standard lib can do. I'm starting, getting a little bit underwhelmed by it. But okay, fine. Okay, let's just take this. Up here, let's do number regex, and that needs to be let const, no, equals regex dot new. I need to copy that inside the brackets, do this, and I need this and an R beforehand. Do you know what the R does? Is it just something special, like a little label to the string or something? Here. Oh, and then we do the dot unwrap. Get rid of that error. Okay. So we find the first number. We find the last number. We can also match. Or we can do it all in one, right? We can then all 0-9 match. Sorry. And we're gonna match exactly one of those. And if we have something like 1, 3 there, and then like this. Okay, that works. Or 0-9 exactly once. Raw string, it disables the escapes. Oh, cool. So it's not okay. Pretty nice. Right, I get it. Oh. Okay, cool. Do we have the same concept as F? Oh no, we don't. Just raw.
Default to string.
Okay. So what we're gonna do is, so we'll leave this for, that's part one. We can leave this for line in reader dot lines. I hope this works. Does this work actually? If I do line, you're gonna run. Oh, I need to do let line equals line dot unwrap that value. Use of moved value. Value used here after move. Yeah. Move due to this call. Okay, so I'm gonna have to kind of do this all inside here. I'm gonna add just another one of you so that I can fold it in place. Inside here, let's move you over. Let's fold you. Let's do another one here. Okay, so we go line equals line dot that doesn't work, right? Oh no, it does. No, it doesn't. Because of, yeah, it's been used before. Okay, so we just get rid of that. Okay. Let us continue. We have to match. So number underscore regex dot match. No. Number underscore regex dot. What are you? String of text. We get results, which is a vector array. Path line number line. So I don't really, like, you know, care that much about that. Captures underscore iterator. Okay, let's have a look. So we have shortest match at static captures read. Shortest match capture is match replace. All captures is match. So these are some of the traits in there. Fine. So what did it have? It had captures iterator. Captures. What do you do? This routine searches for the first match of this regex in the haystack given, and if found, returns not only the overall match but also the matches of each captured group. If no match is found, then none is returned. Okay. Cool, that's exactly what I want. So the haystack is going to be the line. Expect to the pointer. Let's give you a reference to that. A read-only reference. Let res equal that. Need a semicolon, I guess. And you are an option. Yeah. Can I actually, if I do a match on this, and I can do none, can I do panic? Should always have a match. And then what's the other value for none? Sum. Nice. Returns sum, returns v. And result is correctly typed at the captures. Nice. Okay. Getting into habit of things then. Anything else? Just FYI, Rust does have a real pointer for unsafe, so calling ref pointers might get confusing. Oh, right, so we do actually have pointers and unsafe. So I should continue calling them refs. Okay, I'll call them refs then. That makes sense. What do I do here? Res. This is a capture. It's got a name. Capture dot try into. Into what else do we have? Borrow, expand, extract. For extracting the substrings corresponding. Nice. We can subtract. We can extract. This returns a tuple. Let's str underscore. We don't need a second. We know it's going to be matched value. Does that work? If I do not FMT, that's go. Matched value. Consider giving this pattern a type. Use of unstable library feature. Inline panic. Okay. Thanks. Code actions. Is that actually like, can I just ignore it? Add braces to arm expression. No. Okay, you can do your thing. Inline panic. No. Is this gonna crash though? Oh, panic macro. Right, okay. In expressions, underscore can only be used on the left side of. It's not allowed here. Can I just. Do I really need this here? But now you're a tuple, and I don't want you to be a tuple. Match the value. Tuple, let matched underscore value equals matched value tuple dot 0. Oh, really? Come on. It really complains. Destruct tuple. But it really like just doesn't. Okay. I'm gonna. No. Okay. Rust analyzer, go home, you're drunk. Compiling regex, yeah. Use of unstable. What isn't it like? It doesn't like that. Okay. Type annotation needed. Also shortcut for that is oh, okay, so I can do for none. Really? So I can do like, but captures isn't an error, it's an option, so can I still do unwrap? Oh, okay. Right, got you. So now we have. Wait. What? What's he complaining about? Try removing this match. Oh, there's a match there, right? Okay, got you. It really wants this extract to have. Oh, I can do .0 on the end, and then I can just do that, or I can then remove some of this stuff. Consider specifying the generic argument. Oh. No. Bro, what's it doing? Consider specifying generic argument. No. This, and is it usize you need or something? Oh, come on. Simple capture group. So I mean, I want to have matched underscore value here and then just like that. Oh, did you work? Okay. Oh, we wanted like an array type there instead. All right. That took a little bit long. I've not used regex in ages, so I'm guessing here try extract and 0. Little digging deep. Const generics already. Yeah. got to. So you gotta throw yourself in. Yeah, I wanted something H somewhere. Const generic const n usize. Oh, is that like a default value or something? But you can choose anything there. This panics if Namacache if I fix this n in all circumstances. More precisely, routine only works when n is equivalent to set a capture's length. Okay. Okay, and there's a nice example. Well, nice-ish example. Let's call that. All right, got you. Think I got you. And the matched values, were they correct? And I specifically want 3, 8. All right, 3 does work. Okay, so that's good. I think that's good. This is good for the first one, for the first numbers, but now I need the last numbers. And I'm kind of struggling with this because I need regex match last occurrence. Regex last occurrence. Your negative look ahead solution would look like, oh my god, what the hell? You know what? This is actually a good AI question. Let's see if Gemini, Google would tell us. I want to get the last match of my regex expression. Can you modify the following regex to achieve that? Because it's got some look aheads and I cannot remember that syntax, so wait. Well, you can't directly modify regex to extract last match. You can achieve this by no, but this is the last. It's not what I want. Okay, you suck. Every time I go on like on ChatGPT, it doesn't like it. It's returning an array, but it's generic over the size of the array. You'd set it to the number of capture groups you'd use. Right, got you. Okay, so if you had like, I don't know, A, B, C, and you could do like, if I did 2 there, use this, but then C is still relevant. It's kind of strange. Interesting. Okay, what do we have next? What's going next? Well, I have to start from the end, so I have to match again. It's like I have to do a bunch of matches, but the overlap would like kill you. You need to allow for the overlap to happen. Okay, so I think the way I would do this is I would go, yeah, matched value. Yeah, I need to do some function. Number string string number to number, I guess. So s, which is a string, and this is going to be read only, and it's going to return a u32. We're going to do match on s, 1 returns 1, Rust match string. How to match string and string literals. This is the only as string. Oh, it needs to be a literal, like as string. Okay. 2, 3, 4, 5, 6, 7, 8, 9. That's it. 2, no, 3, 4, 5, 6, 7, 8, 9. And before here we could go if s dot length is equal to 1, and well, yeah, I mean we could just do s dot trim. No, probably don't need that dot parse. Return, because it knows the value, so we can do parse here. Dot unwrap the error. Okay, that works. Non-exhaustive. String cannot be matched exhaustive, so wildcard is necessary. Underscore goes into panic. I don't exist. Nice. Let number value equals string. Oh, what did I call it? 7. So there, let's put it there. Matched value. Oh, it's actually not string. Is it just str? Match this function. Oh god. Should this be a pointer? Reference. I guess so. Is matched value a reference to? Yeah, it is. So line number score value. Good. Now I need to do this for the last one though, and that's not very easy because you're gonna have to chop values up a little bit. You're gonna have to go, like if you have 3, 8, it's gonna match on 3, but then it wouldn't match on 8. So what you have to do is you have to like remove the first character, because I don't think any of these become valid numbers if you remove the first. Yeah, none of them become. So we remove the first. We remove the character. So we need to know where it is as well. Like we need to know the position. I don't need to extract a particular value, so maybe I need to do this. I'm doing this wrong. Rust get position of regex match. So great. How do you get position of a group? Get. Oh, capture.get. Okay. Capture.get. Zero. Dot unwrap dot start. What is this? Returns the byte offset of the start. So I mean, we can get the, we can extract the value still. You can get matched underscore index equals capture dot. I mean, this is going to be the first value, so I think I'm going to leave this alone. First number equals that, and then what we're going to do is just, so I have to go away, let's just print first number there. And we're going to do this until there is nothing else to match. So, anything in the chat? You can leave it out. In that case, Rust will infer turbofish is turbofish. Is that what it's called? Reversing string and the regex. Use underscore panic for the default case. Isn't that what I did? Yeah, I don't exist. No, you don't need any help at all. No, do please stay. Lots of help required. So this is a bit weird next, what I'm going to try and do. So I've got the first number extracted, but then I need to almost do the exact same thing, but I need to loop and remove characters, continue, remove, continue, remove. Oh, this is going to be really annoying. Okay, but I'm going to leave that there. I'm going to basically start another one. Shadowing variables actually like kind of useful now, using it. So we're gonna capture, we're gonna unwrap, we're gonna extract the value. We're gonna do get 0 dot unwrap dot start. Okay, so this is match index. Okay, that makes sense. The match index. Let's just print line match index, figure out what that is, and I'm just gonna go with that there for now. So the first number is 3 and the match index is 0. Great. Okay. And what happens if this returns an option, right? Right. Okay, I understand what to do. So we have the capture, we have this. Let's do loop. We're gonna do capture get. Oh, we need capture in here as well. Above. You can find expression is unreachable. Yeah, but we're gonna break, don't worry. We're gonna do match on this. So sum v return v dot start, and then none we break semicolon. The binding match index is available in a different scope in the same function. Oh, got you. It's not really kind of what we want. We want to break out the loop. Ooh, I wonder if I could do let last match equals loop, and here we break with I have to define it before, I think. Yeah, so I do match underscore index is a use size, it's going to be 0. We're going to do match v dot start. So we're going to say that match, let's make you immutable. Match index is this. Otherwise, I'm going to, oh yeah, that just works. I don't need this here. And then we go print line match index. Okay, what are you complaining about? Nothing. Okay. And it goes on forever because I'm not chopping off this line. After you do this, I actually need to change what line is. Let's copy line equals line dot what's line? Line is a string. So line dot to underscore string, no, as underscore string. This is a pointer to a string, and you are mutable. I guess that works. After here, basically I want to do copied line equals copied line dot rust string substring. How to get substring of a string? Ah, okay, same syntax as go. So I want to go from like 1 dot dot. Actually, the match underscore index plus 1 dot dot. Borrowed value, consider this. 3 bytes index 1 out of bounds of where's it crash though? Copy line. Is there anything in the chat? I'll probably also follow your Zig AOC. Take care. Hey, thanks for tuning in. It's been really fun. It's getting too late for me. I hope you continue streaming. Fun watching your devour Rust. You devour Rust so quickly. Thank you. Thank you. It's been a great meal. Yeah, man, enjoy. Let me know. Message me if you want. We'll chat. All right. But the copied line and the capture. I can't believe the match index is 0. There's no way it's 0, right? Every time. It can't just be 0 every time. Match underscore index. Okay. Let's just label that like this. So yeah, first number 0. And then match. Is there? Oh, silly. So should be on a copied line. Do you run? So the first number is 3, and then the first capture is 0, and then the second capture is 3, and then 8. Option dot unwrap. Oh, because there's no capture. Get 0 if there is no capture. Oh, so the match index around here oh, what the hell? Dot unwrap dot start. That's fine, but it's here that I need to do the match. I need to do match on you. Sum v b and none break. Finish that off. Nice, nice, nice. I think that's working. Next. And every single time I kind of want to get get 0 next dot what does get give me? Get gives me a match. My match. Let my match underscore match dot. Oh, as string, and then I can do start. So then match underscore index is equal to my match dot start. And we can constantly reassign second number. We're gonna have let match second underscore number, which is a u32 is 0. We do the index here, and we go second number equals to my string underscore number to this. My match underscore dot to as string. Print first number. Wait. I just realized maybe we don't actually care about. We do care about match index. It's red literally down there. So what are you talking about? When we exit this and this, here we go. First number, second number, value assigned to measure never read. I guess not. Oh, what are you talking about? Rust. Okay. So guys, first number. Oh, it's printing there again. Okay. First number 3, second number 8. Nice. Part 1. Rename it doesn't work. I think I made it crash or something. Part 1. I was gonna say, seems a bit tame. Part 2 plus or equal to first number times 10 plus second number. And then part 2 takes part 2 like this. 281. Lovely. And if we do this, we can call it there for Rust. Oh, that's so fast. 54338, 54338, and 53389. Nice, all done. It's a good time for a commit. Feats, learning, initial bits, and bobs. There is no upstream. Yeah. GitHub repo create learning dash rust dash public. Git remote add origin learning dash rust git push. There you go. There we go. We're all set. Hopefully I didn't push any asset files or something. All seems fairly sensible. Alright guys, whoever's still watching, it's been really fun. I really enjoyed streaming. It's actually the first time I've ever done it. I hope the sound is okay. I hope everything's good. Whoever actually made it to the end. Oh, Dimitri's here. Thank you. Good job. Thanks. You've just had me on the background the entire time whilst you've been working. That's fair. I feel like I drone on a lot, so no, not really. Fair enough. I feel like being on and off. All right, cool. Yeah, well, thank you for tuning in. Very, very much appreciated. Yeah, Rust is pretty cool. It's very interesting, very strange actually coming in and learning this language. It seems very different to other things that I'm used to. Yeah, thank you, Isaac, for coming in, and for James as well. Cheers, guys. All right, when I figure out how to turn the stream off, we'll call it there. Yeah, hopefully that all went well. And yeah, how do I turn the stream off? It's pretty good. Anyways, guys, Thank you so much. See you later.